Hello viewers, I am Dr. Robiul. I work as a lecturer in pathology in a medical college hospital, and I am making this video for my students and also for you. Hope someone finds this helpful. Today's topic is on cytokines. This video will contain the definition of cytokines, followed by the cells that are involved in its production, sites of action of cytokine, followed by brief discussion on cytokines that are involved in inflammation, functions of various cytokines, roles of cytokines in immune responses, and we will finish our discussion today with the therapeutic applications of cytokines. Okay, so a lot of topics, so let's begin. First question, what are cytokines? Now, the word cytokines is derived from two Greek words. The word cyto is derived from a Greek word that means cell, and kines is derived from another Greek word that stands for movement. So the literal meaning of cytokine is cell movement. But in reality, you will see that cytokines are involved in much more complicated processes than just moving cells around. As a matter of fact, cytokines can be considered the messenger molecules of our immune system, and they help in cell-to-cell interaction, particularly among lymphocytes, dendritic cells, macrophages, and other inflammatory cells, as well as between endothelial cell and connective tissue cell. So always remember that cytokines are the messenger molecule, and they have role in cellular interaction, particularly among the cells that are involved in inflammation and in immune responses. So how can we define cytokines? Cytokines can be defined as proteins produced by many cell types that modulate the functions of other cell types. And in your newer edition of textbook, you will see a slightly modified definition, so I have also included that definition here as well. So in your newer edition of textbook, you will see that cytokines are defined as proteins produced by many cell types that mediate and regulate immune and inflammatory reactions. Okay, I hope you're still with me. You didn't run away just like my students do when I try to teach them definitions of pathology. I even have to show them teddy bears to keep them calm. So look, I'm also showing you a teddy to keep you calm. So don't run away, because I will explain this definition line by line now. So from the definition, it is clear that cytokines are proteins, and they are produced by many cell types. Now we may be asking Dr. Robiul, what are the major cells that are involved in cytokine production? And always remember, they will include activated lymphocytes, macrophages, and dendritic cells. So these are the three major sources of cytokine. However, also you have to remember that endothelial cells, epithelial cells, even connective tissue cells, they can also be involved in cytokine production. Moving on to the second part of the definition, we can see the role of cytokines. So what do they do? These are proteins. They are produced from different cell types, and their role is to modulate the function of other cell types, particularly the cells that are involved in either immune responses or in inflammatory reactions. So now that we have defined cytokines and explained the definition, now we will move on and talk about the cells involved in cytokine production. As a matter of fact, I have already mentioned their name when I was explaining the definition. So can you recall the cells that are involved in cytokine production? Yes, they will include, like I said, activated lymphocytes, macrophages, dendritic cells, endothelial cells, epithelial cells, and connective tissue cells. And also remember that the first three cells were the major sources of cytokine production. So the next thing that should come to our mind is, where do these cytokines work? What are the sites of action of cytokines? Now always remember, the majority of these cytokines will either act on the cells that has produced them or on neighboring cells. And when these cytokines are acting on the cells that had actually produced them, that is autocrine actions, and whenever they are acting on neighboring cells, that type of action is considered paracrine actions. And very rarely they can also act on distant sites, and that is known as endocrine actions. So always remember that in majority of the time cytokines will act either in autocrine or paracrine manner. However, rarely they can also act in endocrine nature as well. Moving on to the next topic, now we will talk about cytokines involved in inflammation. Now I have 4 separate videos on acute inflammation, chronic inflammation, and phagocytosis, and you can also watch those videos after watching this video for more information about inflammation. But to say in short, always remember that inflammation is a complex reaction that happens in vascularized tissue, and in that reaction there is response of the blood vessel, and also there are some cellular events, particularly by leukocytes. So that is inflammation, and inflammation can be acute or chronic in nature, and certain cytokines are involved in acute inflammation, certain cytokines are involved in chronic inflammation, and some are involved in both. So what are the cytokines that are involved in acute inflammation? They include tumor necrosis factor or TNF, interleukin 1, interleukin 6, interleukin 17, and chemokines. Moving on to the cytokines that are involved in chronic inflammation, they will include interleukin 12, interleukin 17, and interferon gamma. And note that interleukin 17 is involved both in acute as well as chronic inflammation. So now we will move on and talk about the function and also the source of these different cytokines, and we will begin our discussion with tumor necrosis factor and interleukin 1. So what are their sources? Always remember, tumor necrosis factor is produced in the macrophages, mast cell, and also in the T lymphocyte, and interleukin 1 is produced in macrophages, endothelial cell, and also in some epithelial cell. And as we will see, tumor necrosis factor and interleukin 1, they have similar function. Just remember that interleukin 1 has a greater role in development of fever. So now I am showing you a simplified diagram depicting the different functions of tumor necrosis factor and interleukin 1. But also note that in order for these things to happen, the major source of these cytokines, that is the macrophages and some other cells, those things must first be activated. So who activates the macrophages? Always remember, microbial products, toxins, and some other cytokines are responsible for the activation of macrophages. Once the macrophages are activated, they will produce and release tumor necrosis factor and interleukin 1. And these two cytokines will have local effects as well as systemic effects. And as we can see from the diagram, in the local effects, we can have effects on the endothelial cell, on the leukocyte, and on the fibroblasts. So let's talk about these effects one by one. So what will be the function of tumor necrosis factor and interleukin 1 on endothelial cells? In your textbook you will see a term that is endothelial activation. Both tumor necrosis factor and interleukin 1 will act on endothelial cells, and they will induce a spectrum of change, and that spectrum of change is referred as endothelial activation. So what will we see in endothelial activation? There will be increased expression of adhesion molecules. Now recall from my videos on inflammation that during inflammation there were vascular events as well as cellular events, and during these cellular events the leukocytes initially had to roll and tumble, and later they had to adhere with the endothelial cell before they can get out of the blood vessel and move on to the site of injury. So adhesion is an important part of inflammation, and tumor necrosis factor and interleukin-1 will increase expression of endothelial cell adhesion molecules. And you may now ask me, Dr. Robiul, which adhesion molecules will be expressed in higher number by the role of tumor necrosis factor and interleukin-1? And the answer will be E-selectin, P-selectin, and ligands for leukocyte integrins. So always remember that tumor necrosis factor and interleukin-1 will have a very important role on endothelial cell, that is called endothelial activation. There will be increased expression of endothelial adhesion molecule, mainly E-selectin, P-selectin, and ligands for leukocyte integrins. And at the same time there will be also increased production of some other mediators like cytokines, chemokines, growth factors, eicosanoid, and also there will be increased procoagulant activity and decreased anticoagulant activity. And all these things combined will result in the term referred as endothelial activation. Moving on to the role of tumor necrosis factor and interleukin-1 on leukocyte. In short, they will activate the leukocyte and they will also increase production of cytokine. So which leukocytes will be activated mainly? Always remember, tumor necrosis factor will activate neutrophil. They will augment the response of neutrophil to some stimuli. For example, the response of neutrophil to bacterial endotoxin will be augmented, and at the same time tumor necrosis factor will also have a role on macrophages. They will increase the bactericidal or microbicidal activity of macrophage, and that will be done with the help of nitric oxide. So always remember, tumor necrosis factor will have role on neutrophil and macrophage. On neutrophil, its role will be to increase the response of neutrophil to some stimuli, and on macrophage the role of tumor necrosis factor will be to increase the microbicidal activity of the macrophage with the help of nitric oxide. Regarding interleukin-1, interleukin-1 will stimulate the T helper 17 response, and that will help in acute inflammation, that will induce acute inflammation. So these were the roles of tumor necrosis factor and interleukin-1 on leukocyte. So moving on to the next local effect, that was their role on fibroblast. What will they do on fibroblast? They will increase the proliferation of fibroblast, and they will increase collagen synthesis from the fibroblast. So these were the roles of tumor necrosis factor and interleukin-1 which had local effects. But from the diagram you can also see that they also have systemic effect, and this is a very high yield topic. The examiners are very fond of asking what are the systemic effects of tumor necrosis factor or interleukin-1, and as we will see that these effects will include fever, leukocytosis, increased amount of acute phase proteins, increase sleep, and decrease appetite. And all these things are also known as the systemic effect of inflammation. So as you can see, the systemic effects of inflammation are mainly mediated by tumor necrosis factor and interleukin-1. Now these systemic effects of inflammation are also collectively known as acute phase response. So let's talk about these different systemic effects of inflammation one by one. So the first one that we will talk about is fever. Always remember, during inflammation our body temperature will rise. Usually 1 to 4 degrees Celsius elevation will be seen during inflammation. And any substance that can induce fever is called pyrogens, and pyrogens can be exogenous or endogenous. And interleukin-1 and tumor necrosis factor, they are in fact endogenous pyrogens. But then you may be asking me, Dr. Robiul, then what are exogenous pyrogen? Usually bacterial products like lipopolysaccharides are in that group. They are in fact exogenous pyrogen. So what happens here? During inflammation, the exogenous pyrogens, for example the bacterial products like lipopolysaccharide, will first stimulate the white blood cells or the leukocytes, and then those stimulated white blood cells or leukocytes will release interleukin-1 or tumor necrosis factor. Recall that interleukin-1 and tumor necrosis factor are endogenous pyrogen. So the point I'm trying to make here is, during inflammation, if that inflammation was due to some infectious cause, then the products of the bacteria or other infectious agent will first stimulate leukocyte, and then the leukocyte will liberate endogenous pyrogens. And what will happen next? Interleukin-1 and tumor necrosis factor will increase enzyme of cyclooxygenase pathway of arachidonic acid metabolism. Now always remember, in our cell membrane we have phospholipids, and those phospholipids can be broken down into arachidonic acid by the enzyme phospholipase. Then the arachidonic acid can be further metabolized in two pathways. One is called the lipoxygenase pathway, where we get different leukotrienes as the end product, and the other pathway of the arachidonic acid metabolism was cyclooxygenase pathway, where we get different types of prostaglandins. So the point I'm trying to make here is, once the leukocytes are releasing interleukin-1 and TNF after being stimulated by exogenous pyrogens, the interleukin-1 and tumor necrosis factor will increase production of enzymes of the cyclooxygenase pathway, and that will convert a lot of arachidonic acid into prostaglandins. And in the hypothalamus, prostaglandin, especially prostaglandin E2, will have a role. Prostaglandin E2 will stimulate the production of some neurotransmitter in the hypothalamus, and those neurotransmitters will reset our temperature set point at a higher level, and that is when our body will get fever. Now in your textbook you will see that in amphibians, fever or elevated body temperature acts as a protective response. The amphibians can kill different microorganisms that are infecting them by increasing their body temperature. And it is also assumed that fever may also have some protective response in humans and other mammals as well. So a lot of researches are now going on these things, and the exact mechanism is still unknown. One hypothesis is that during fever there may be increased production of heat shock proteins, and those heat shock proteins can enhance the response of the white blood cells against microorganisms. So also keep that thing in your mind, that in fever, heat shock proteins may be produced, and those enhances the antimicrobial capability of our white blood cells. The next systemic effect of interleukin-1 and tumor necrosis factor that we will talk about is regarding production of acute phase proteins. Now, what are these acute phase proteins? Always remember, these are plasma proteins. They are produced mainly in the liver, and their plasma concentration can rise to several hundred-fold during inflammation. The common acute phase proteins will include C-reactive protein, fibrinogen, and serum amyloid A. And interleukin-1 and tumor necrosis factor have a role in increasing the production of these acute phase proteins. Mainly, serum amyloid A production will be increased by interleukin-1 and tumor necrosis factor. Then you may be asking me, Dr. Robiul, then which cytokine is responsible for increased production of C-reactive protein and fibrinogen? And the answer will be interleukin-6. And we will talk more about interleukin-6 briefly afterwards. The next systemic effect was leukocytosis, that is, elevated level of white blood cell in the blood. And usually interleukin-1 and tumor necrosis factor are responsible for this type of elevation. Now, leukocytosis can happen by various mechanisms. Initially, leukocytosis can happen as a result of accelerated release of cells from the post-mitotic reserve pool of the bone marrow. Now, note the term reserve. That means these cells were already produced in the bone marrow, however, they were kept inside the bone marrow as reserve cells. It's like the reserve army. Normally, during peacetime, what do we see? We see that a vast portion of the army is not mobilized. They are kept as reserve force inside the barracks, right? Similarly, during normal condition, a lot of post-mitotic reserve pool were created in the bone marrow. But when the time comes, when the body needs them, what is happening? Cytokines like tumor necrosis factor and interleukin-1 are sending signal to the bone marrow, and the bone marrow then releasing those cells into the blood. But the problem is, these newly released cells, the cells that are released inside the blood from the bone marrow reserve pool, those cells were immature. And what will happen then? There will be shift in the maturity of the cells found in the blood, and that is the term known as left shift, as you will see in your textbook. So just remember that leukocytosis initially will happen as a result of accelerated release of the cells from bone marrow post-mitotic reserve pool. However, those cells will be immature, and there will be rise in the number of immature cells, mainly immature neutrophils in the blood, and this is referred as something that is left shift. The second mechanism by which leukocytosis can occur will involve colony-stimulating factors. Colony-stimulating factors can stimulate the proliferation of certain precursor cells in the bone marrow, and that will result in leukocytosis as well. The other systemic effects of interleukin-1 and tumor necrosis factor were increased sleep and decreased appetite. So now that we have talked about the sources and functions of interleukin-1 and tumor necrosis factor, now we will move on and talk about the other cytokines that are involved in acute inflammation. So here I am showing you a table, and here we can see the rest of the cytokines that are involved in acute inflammation. So interleukin-6, the major source of interleukin-6 is macrophages. It is also found in some other cells as well. And we have already mentioned the function of interleukin-6. Can you recall the function of interleukin-6? Yes, it had a role in production of acute phase protein. For example, C-reactive protein and fibrinogen. Those things were produced in response to the cytokine interleukin 6. The next cytokine that is involved in acute inflammation is a group, and that group of cytokine is known as chemokines, and they are found in a lot of cells. They are found in macrophages, T lymphocytes, endothelial cells, mast cells, etc. And chemokines have a lot of function, as we will see. So now you may be asking me, Dr. Robiul, what are chemokines? Always remember, chemokines are a family of proteins, and their major function will include acting as chemoattractant for certain types of white blood cells. About 40 different types of chemokines have been discovered, and they work on 20 different types of receptors. So we get the idea of their function from their name. So chemokine will help in chemotaxis, that is recruitment of leukocytes to the site of inflammation. However, chemokines also have another function. They help in migration of cells in normal tissues as well. So also keep that thing in your mind, that not only they help in recruitment of white blood cells in the site of inflammation, they also have another function, and they also help in migration of different cells in normal tissues. The next cytokine involved in acute inflammation is interleukin 17. Now always remember that interleukin 17 will also have a role in chronic inflammation as well. So what is the source of interleukin 17? T lymphocyte is the source of interleukin 17, and it helps by recruiting neutrophil and monocytes to the site of inflammation. So now that we have talked about the cytokines involved in acute inflammation, now we will move on and talk about the cytokines involved in chronic inflammation. So I am now again showing you another table, and here we will see their principal sources and their functions. So what are the cytokines involved in chronic inflammation? We had already mentioned their name during the first half of this video, and they were interleukin 12, interleukin 17, and interferon gamma. So let's talk about these things one by one. Interleukin 12 is produced from the macrophages and dendritic cell. And interleukin 12, their major function is to increase production of interferon gamma. Now always remember, interferon gamma is the cytokine that activates macrophages. You know, normally macrophages they are killer cells, but they are not in a killing mood. They are just chilling around. But when they are activated by the interferon gamma, they transform themselves. The macrophages suddenly become a very fearful killing machine. You know, it is now all pumped up and ready to kill different microorganisms. So that is the role of interferon gamma, and interleukin 12 increases production of interferon gamma. So that was the function of interleukin 12. Moving on to the next cytokine that is involved in chronic inflammation, and that was interferon gamma. So I have already mentioned their function. They activate macrophages and increase the ability of the macrophage to kill different microorganisms as well as different tumor or neoplastic cells. The major sources of interferon gamma will include T lymphocyte and the natural killer cells. And we have already mentioned the source and function of interleukin 17. So before finishing today's video, we will just touch one more topic, and that is the role of cytokines in immune response as a whole. So always remember, cytokine will have a role in both the innate immune response and also in the adaptive immune response. And also cytokines can stimulate hematopoiesis with the help of colony stimulating factor. Now, we have already talked about the majority of the cytokines that are involved in innate immune responses when we talked about the role of cytokine in acute and chronic inflammation. So, cytokines that are involved in innate immune response will include tumor necrosis factor, interleukin-1, interferon gamma, interleukin-12, etc. And the idea is, when our body is exposed to microorganisms and other stimuli, these cytokines are produced rapidly and then they induce inflammation, and by inflammation our body tries to protect ourselves from the harmful effects of these microorganisms. Some cytokines will also have a role in adaptive immune responses as well, and they are mainly produced from the CD4 positive T lymphocyte, and they will include interleukin 2, 4, 5, 17 and also interferon gamma. The main functions of the cytokines involved in adaptive immune responses will be to promote white blood cell proliferation, differentiation, and also to activate other effector cells of the adaptive immune responses. Moving on to the next function, some cytokines will have a role in hematopoiesis. They will stimulate production of blood cells from the bone marrow progenitor cells, and they are known as colony stimulating factors. The common examples of colony stimulating factors will include GM-CSF, that is granulocyte macrophage colony stimulating factor, interleukin 7, etc. The last topic that we will touch in today's video is regarding the therapeutic applications of the knowledge about cytokine. Why do we need to know about cytokines? One example is to control the harmful effect of inflammation and immune reactions. We know that although inflammation is a protective response, and although immune system serves to protect our body, sometimes they can also cause tissue damage, for example in rheumatoid arthritis. So in those cases, if we can inhibit cytokine production, if we can inhibit some specific cytokine production, that can be beneficial for the patient. For example, in patient who has rheumatoid arthritis, we can see some good response with the use of tumor necrosis factor antagonist, the drugs that will inhibit the function of tumor necrosis factor. Another therapeutic application of cytokine can be to boost our protection. For example, in certain cases, we may need to increase our blood cell production, that is, we may need to increase hematopoiesis, and also we may need to increase our protection against certain viruses, and in those scenarios administration of cytokines will have a lot of beneficial effect. Another very important therapeutic application of cytokine is seen during stem cell transplantation. Now, in order for stem cell transplantation to occur, first we must collect stem cells, right? And there are various methods for collecting stem cells. One method for collecting stem cell is by mobilizing stem cells from our bone marrow to the blood, and then we can collect the stem cells easily from the blood. And cytokines can have a role here. Cytokines can induce the mobilization of stem cell from the bone marrow to the peripheral blood, and then we can collect those stem cells for stem cell transplantation. So this concludes today's video on cytokines. I hope this video was helpful. If you like my videos, do comment, share, subscribe and let me know. And for my students, I will recommend you to go through your textbooks for more informations. So that's all for today. Until next time, take care and stay blessed. Thank you.